Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about cleaning the mining industry itself. So let's dive deep into it. Now you have to understand, mining is what we classify as necessary evil because here's the core reason why human ascended from an animal kind of a species to a human is because of it. Because the moment we finally understood that we can get metals out of rocks, basically stuff, and we can get stuff out of it, that changed the game. Now, here's the problem with that. This puppy is 100% non-renewable, meaning even with fuels, you can have biofuels and they keep cycling as long as sun is there, you're good. But when you're talking about minerals, no. And sometimes we literally transmutate, basically, especially if you are talking about radioactive stuff, they change, done, go home. Like it can't come back. So mining is one of those things that we have to fundamentally understand that it will run out. That will be very clear. It's not today, but it is eventually. The question is not if, question is when. It's almost like coal. Now, does Earth's crust have enough coal? Yeah, most likely it has. Can we extract it? No. We can only do easy to extract kind of stuff. So there is a fundamental cap on everything that we are dealing with. So sooner or later we have to figure this thing out. And it's that part is long-term issue, but short-term issue is that this is one of the worst polluter. Now you have to understand, to simplify pollution, we have to understand there are scopes of it. First example is scope number 1, meaning you drive your car, you see petrol going in, CO2 coming out. That's a thing. That's a scope 1 emission. You see a power plant, you see coal trucks going in, poof, you see the emission. That's scope 1. Again, burning your gas for water heater or house heating, scope 1. Scope 2, it's a bit of indirect kind of system, basically transportation of goods and services, basically waste generation and disposal, and business travel, employment, commute, everything basically comes into second tier. And third tier is indirect. Basically, if you're buying a mobile phone, you're not thinking about pollution, but it's still happening. So that's what we call downstream activities, is scope 3. Now, when it comes to mining is daddy in scope 1 and scope 2. What does that mean for us? Well, if we converted all our basically industries, basically power, right? Let's say you are like, hey, all cars have to become electric car. Would that solve pollution? Hell no. Why? These things are still there. Like flat out, this is something that we are almost ignoring, but we have to look into it because in terms of scope 1 emission and scope 2, it has bonkersly large footprint. On top of that, it also releases other things that we are not intending to, meaning especially with coal mines and all that, they also dump a methane and sulfur and stuff that we do not want. So it is the worst polluter. Other things like especially fossil fuel generally only pollutes one of the two ways. So one way is CO2 in the atmosphere, another way is microplastic. This is like, bro, hold my beer. I do everything. So it pollutes the air, it pollutes the soil, it pollutes the water. Acid mine drainage is one of the worst thing ever. Like almost whole humanity has a good understanding by 1990s that mining is not sustainable. Like I'm talking 1990s. Acid mine drainage was becoming a thing. People were like, whoa, this is bad. So mining is something problematic that we have to solve, and well, is the worst one yet. Even trying to solve it, like most people will give up. It's like that's how complex it is. So there is a paradox nature to it. Well, the reason is we want to make green technology, right? The moment we realize fossil fuel cannot be used, the first thought we had is that where the heck fossil fuel is being consumed? It's consumed by our transportation. That's everybody can tell, oh, I put petrol in my car, I put gasoline in my car, I put diesel in my car, and same goes with other stuff, right? So everybody knows this. But here's the deal. How the heck you got that? Again, like you have a car, where the heck steel came from for that car? Again, mining had to be done for that. So same goes here. If we can replace all the cars with other stuff, let's say all the power plant with solar and wind, cool, awesome. But here's still where the material to build those come in. So we do need a lot of material for mining, and we have to consume mining. We have to deal with mining. We have to just accept it that you cannot do transition if you do not do mining. Well, here's the deal. Now, question is, many times people will try to obfuscate you, is like, or lie to you flat out. It's like, oh, then what's the benefit? We can just stay using oil. Well, here's the deal. While it is factually true that Mach 1 electric cars, like that we were building in 1990s, they were consuming too much and useful life was too little compared to petrol one. However, At this point in time, the footprint is low. Is it lower than petrol car? No, but it's low enough. Now, how the heck is it makes any difference? Because it's not continuously emitting it. It's basically, you have a carbon footprint, let's say X. Your petrol car is X divided by 2. Cool. So it's half. So that means petrol is better. Yeah, that's the car footprint, not the fuel it's going to consume. So over lifetime, it does not consume 1 kilogram of fuel. It consumes hundreds of liters of it. And that's a civilian use. And if you're talking about big diesel truck, they have tanks that are like 500 liters, or some of the big ones are like kiloliters. Jumbo jets are measured in kiloliters. And let's not even go into dump trucks. They do not even use liters. They have to use gallon because it's so freaking huge. So fundamentally, that the moment you add that into the equation, it's like, yeah, the electric car is definitely a much less polluting choice. Same goes with solar panels. Solar panels that were made in let's say 1980s, they were very polluting. They were very inefficient methodology. We did not knew enough. There was not enough competition, so we just like do whatever it is. So footprint of the panel itself was like so much that you would be better off just burning coal. However, that's not true today. We have refined this puppy, improved it, competition happened, capitalism helped this puppy. So we have reached a point where at this point in time, the carbon footprint of solar panel is one of the lowest. Let that be very clear. The lowest, as in, if you're like, hey, wouldn't it be lower carbon footprint if I use, let's say, water dam? No, water dam has giant amount of concrete. That concrete has higher CO footprint with this. So we have, again, that's how it happens. Mark 1, Mark 2, Mark 3. Like imagine telling someone like, oh, you're gonna have like, mobile phone that has 256 gigabyte to a people in 1980. Well, they were like, what are you smoking, man? And what is this gigabyte? Kilobytes were their imagination. So fundamentally, it happens. That's how we go. So there is nothing wrong with pursuing. So people are like, oh, the wind turbine consumes so much more power compared to how much energy it gives. Yeah, that will always happen with Mark 1. That's supposed to happen with Mark 1. It's like it's expecting a baby to come out and know how to do, live in the world. That's not how it works. You have to go from Mark 1, Mark 2, Mark 3. And we have to do it because in all scenarios, once we become good enough, even competent enough, we reach a point where it's like, yeah, this is fundamentally better. Same happened with wind turbines. Wind turbines were very small, 2 megawatt wind turbines. They were really polluting. But once we learned, it's like, hey, it makes more economic carbon footprint sense to make these puppies bigger. How big we are talking about? Nowadays, all the offshore farms, those puppies start at 12 megawatts. And because they are offshore and they are like getting cleaner air, their yield is much higher. So on time is much higher. So their carbon footprint is now slowly starting to revert. Solar has already crossed that. Wind is almost there where we are almost seeing it happening. So that's why do not file for that. It was like, oh, it has footprint. Of course it has footprint. It's supposed to have footprint. It's just that we are working our ass off to reduce it. And it makes economical sense to do so. So people will do it. Now, there is no way around it. Let that be very clear. If you're like oil versus renewables, you have to deal with mining either way, right? Either way, no matter what you do, you have to deal with this fundamentally. And what about recycling, right? People may think, what if we recycle it? Yeah, especially when it comes to renewable technology, we have not used enough of it. For example, lead. If you are talking about battery industry, lead acid battery, we are not making that much new lead acid battery. And heck, more and more we are transitioning away from it. So demand is not there, and enough of them is there, enough of them is cycle. That's like we reaching a point where it's like we may not need to make too much more new lead. Can that be done with lithium? No. Can that be done with all the stuff that is going in solar panel? No. Why? We are still in the consuming phase. We are growing right now. So this will take at least few decades before we reach a point where there is enough cycle in the market, enough mass in the market that recycling is the primary source. It's not going to happen on day one. It's a very long-term thing. So right now we have to deal with mining. There is no go. And again, some amount will always be lost. And when you're talking gigatons, some amount still means hundreds of tons. So we have to deal with that. Recycling will not just magically save us, not yet. And so what can we do? Well, we have to try to do as harmless as possible. We cannot make it perfectly, rosy and all that. It is like, a bitter pill to swallow. And again, we can reach a point when humanity finally conquers the space, but that's very, very far away. So for our sake and for our planet's sake, we have to make it as harmless as possible. And one thing that I do respect about Donald Trump, he's very clear about that, is out of sight does not mean, out of sight, out of mind does not mean it's okay. For example, many people are like, oh, why don't we do renewables and this and all that, and like, just force it by law. It's like, have you actually thought it through? We have no replacement for these things. And if we just brute force it without solving all other related issues, we're just going to create another mess. Only difference would be for short duration, it will be out of sight. You will not see it. Oh, acid mine drainage. First day, you will not see it. Like, oh, why Europe is so clean? Because all the acid mine drainage that because of their mineral consumption is happening in China. They're like, we don't know. I was like, oh, why, USA has clean water? Well, because all the urine is going into freaking Bangladesh. Again, clothing industry I'm talking about. So it's one of those, out of sight does not mean it's fixed. Again, same with battery elements and all that. Neodymium and all that. It's like, there is genuine things that you have to worry about, and we are not there yet. So that's why it's a paradox. We have to think it through, process it through, then not just like, oh no, like, how dare you. The moment you do how dare you, you're poofed yourself. So what are the big steps? Well, first step is extraction. So whenever we want to get something, you have to understand it's present everywhere. Meaning, I want gold. Yeah, it's in the seawater. Then why don't we extract it? Well, here's the deal. Let's assume the price of gold is X. Trying to extract it from seawater will cost you 5X. So it's not worth it. That's why you have to understand ppm matters, parts per million. It's always, almost every element is there everywhere. It's just that mining sites are specifically chosen because they have concentration of it. It's not like USA does not have thorium or India does not have neodymium. We got it more than enough. It's just that it's not easy enough. So that's what mine means. It's easy enough. So getting to what we need requires energy, a lot of it. So what steps we are talking about? Step number 1, drilling. We generally start with this. Then we do kaboom to that. Then we do excavation, like actually taking the stuff out. Then we do transportation. Now, of course, you will may have grinding if transportation requires a bit of love and effort. But these are the big puppies that consume energy. And thankfully, this is one good thing. Thankfully, most are doable by renewable power, and some are already renewable. For example, open pit mining, Big Daddy. Now, these things are big, huge, and they do not consume diesel. It's like, how the heck they're running? They're running from power plant. So it consumes almost, I think, 18 megawatt. Now, here's the interesting part. It does not give a damn where does that 18 megawatt come from. It could come from coal power plant, it could come from solar farm, it could come from wind farm. It does not care. It's 18 megawatt, take it and go. So a lot of things can be done like this. And for example, transportation does require huge batteries, and I'm talking like big batteries. Thankfully, people have realized that, again, mining industry is a long-term operation. Like, you start a mine, and if your calculations are right, and early testing will kind of prove it, like in few years only, it's like, is it worth it or not? Yeah, those mines could be operated for 20 years or 30 years. So in those sort of scenario, people know that oil prices, if I'm running my dump trucks on diesel, that's cool and all. It's just that in few years, it will cost so much more that it will be no longer profitable. Every company has come to the same conclusion. And again, we kind of knew this. That's why these things made in 1980s were also doing that. So the idea is, what if this can be done on battery? And you can utilize, again, solar, wind, or even if, let's say, you have solar and wind in some of the places, and you do not have large enough battery storage, no problem. Even if you have a coal power plant that is providing the grid inertia and 24/7 part, even if you can reduce the coal consumption, that still translates to good reduction of emission. So Hitachi is just 1 month ago released their dump trucks. Now, dump trucks generally mean big daddies. How big daddy we are talking about? Up to 600 tons. So yeah, they're big. And how they are doing it, again, battery, motors and all that, those are the sorted part. Is just like, how the heck you're going to charge it? Because these things have to work 24/7. They're like, hey, the mines are huge, like freaking huge. So they have a track, a ramp up track where you ramp up. So they're like, hey, what if we charge it during the ramp up part? Dump enough power to drive the motors, enough surplus to charge the battery, and you just go. And once you dump it, then you ride down to the bottom of the mine. Again, regenerative braking, you charge some batteries energy. So doing all of that, then it's like, So they're testing right now. And again, I'm reasonably sure that if it has any probability of working, I can guarantee you by 2-3 years, there will be 5 or 6 companies making this. So I like the idea. They are using catenary, and because this is completely one thing, made for one thing, it can actually work. Not like putting catenary on highways. This is far more logical. So it can be done. And again, big things can be done. Conveyor belts are already electric. So a lot of things can be done. Now, what about booming part, the boom part? It's difficult. Let that be very clear. It's difficult. Can we do it? Technically, of course. All you have to do is like have a refrigeration unit, and refrigeration as in like cryogenic level refrigeration unit, and water. And you split it with hydrogen and oxygen. And then you convert it into liquid oxygen and liquid hydrogen and boom it. Trust me, it has more boom power than RDX. So yes, it can be done. And liquid oxygen has been used as a boomer stuff. So that can be done reasonably enough if we really want to remove that. And we may want to do that simply because the boom powders that we use, they are very toxic, not only in terms of the land, in terms of manufacturing also. So many people may be like, yeah, let's just, again, it is difficult, not the electrolysis part, we good. It's just how the heck you have a small enough plant to cryogenically convert it. If that can be done, I can easily see that. It's like, hey, you need that. We start the plant in the morning. By afternoon, you have like canisters. You take the canister, of course, two-part component, that's the safety part. Only when you are ready to go boom, you put those canisters in the same place, have a small detonation or electric arc. So that can be done. So it's messy, but it can be dealt with. And here's the deal, why people are doing this. This is one part. It's profitable. It's logical for a country to invest in this sort of stuff if they can save diesel. And again, ironically, same thing was done in Soviet Union when they were like, hey, we have so much oil, we can sell it to the world. We have so much oil and gas. So they were like, hey, transportation industry, this is like early 70s. So they're like, hey, but our transportation industry consumes so much. They're like, hey, what if instead of normal bus running on diesel, we use trolley bus? That's why Russia has so much trolley bus. This is basically same trolley bus supersized. So it's profitable. Like it's economically viable. So once something becomes like this, it's logical to do and support. And if government is just like, hey, we're just going to give you a tax rebate, not even do anything, just we're going to give you tax rebate if you do this sort of thing, I can easily see things like this catching up. Now, of course, it's not ready for prime time just yet. I do expect 5 years more, but we are almost. So extraction part can be sorted. Then we come to the processing part. Now, processing part generally consumes two puppies. So one is chemicals, another is lot of power, like bonkersly large amount of power. As in, like if you want to figure out like where the majority of national energy is going, yeah, surprisingly large number of them is going into processing industry. And there is a problem with that it consumes high temperature, like very high temperature, and they also need 24/7. Like there are certain industries, especially like glass industry and things that have continuous furnace, they cannot turn it off. Like of course they can turn it off, you can cut power, it turns off. You do not want to, it will destroy it. So they have to plan it out. Like shutdown is a process, it's not just like, oh, shut it off. So you cannot have like, oh, we have so much cheap power in afternoon due to some solar, we can run the plant in the daytime and then just like run it on next day time. No, they cannot do that. So many processes are like that, where they are temporarily consistent. They have to be running 24/7. Some are batch design, so you can do in small batches. Others are not. So they do require high temperature and they do require 24/7. And if you want to make sure your country is rich enough, as in healthy enough economically, it has to have cheap processing industry. This is one of those things that cannot be bargained with. You cannot be like, okay, for environmental system, we're going to turbocharge the pricing. Yeah, your country is going to starve to death. This is not negotiable. That's why I keep talking about like you always need cheap and abundant power. Cheap part is for this, and abundant because it does consume a lot. So thankfully, there has been some progress made. Right now, this AC that I have right now, it's a winter in India, but this AC is running as a heat pump, as in it has that 4-way valve, and I'm getting heat out of it. Somebody realized, hey, instead of spending money on electric heaters or spending money on gas, while you're like, wouldn't gas be cheaper? Yes, but anybody who has long-term vision, again, these factories are not meant to be like, oh, I built it today, I'm going to dismantle it tomorrow. They plan it for 20 years, 30 years. If they have traced basically inflation and traced the fuel cost, they're like, yeah, if we do not switch right now, it's going to be bad. So more and more companies that have good sort of financial handling on the situation, they're like, yeah, let's switch to heat pumps. Why? Low cost. And again, this is the most desirable part. You never want to force people to switch because it's like, it's for the environment. Never do that. Never go, how dare you? Always be like, hey, would you want to save money? They will do it willingly. And of course, then you can give them incentives to like, smooth the process, because somebody has to take the risk and it will always be the risky the first time. So that's why you do need that elbow grease. So it is one of those things. And thankfully, things are being moving forward. So basically for drying steps of clothing and pharmaceutical industries, a lot of processes can be automated like greenified, rather than using gas fires or electric heaters. They can use heat pump and reduce the carbon footprint. That's good. Now, so far, so good. It's much harder the moment you start to reach any temperature that is classified as high temperature, aka 1500 degrees Celsius plus. That is very difficult. How difficult? Well, there is no technical technology to achieve that. So for example, furnaces, many, especially one dealing with magnetic metals, they use induction. We cannot physically have something that is that hot. And even arc furnace is the arc that is the hot. It's not the metal parts, like the metal prong that you see, the three prongs. The prongs just go in. The arc happens in between that. That is the doing the melting part. So fundamentally, you just say 1500 degrees Celsius is very hard. Yes, we can achieve it. It's very, very hard because the electrical resisting water, they are very cool, very awesome to 500 degrees Celsius. 800 degrees Celsius, okay. 1000, there are only few metals that can even withstand that without getting oxidized. And like, what if I encapsulate it into inert environment, let's say, do that, but again, then how will you conduct the heat away? All of those issues happen, but it can be pushed. But the moment you start to cross 1500 degrees Celsius, those are like, yeah, no. That's why we go to inductive heating or arc furnace. So is there a solution to this? Thankfully, a new technology is making waves. That is this puppy. So the idea is high temperature energy storage. Now, thermal energy storage, we are not talking about electricity. So one thing you have to understand, energy does not matter which factor you're talking about, does not matter which version you're talking about, which variant you're talking about, it does not like to be changed. So you have basically electrical energy, it does not like to be changed to thermal energy. But once you do that, do not change it back. Once you change it to electrochemical, do not change it back. Once you change it to hydrogen, do not change it back. It does not like changing back. So what if your requirement is heat itself, right? You do need bonkersly large amount of heat. What if you convert electricity once into heat and done? And the heat itself is what you store. So now you have the benefit. You basically have a plant, and then you have a giant solar farm, or basically a whole nation back feeding you during the peak time. And you turbocharge this graphite block. Now, why graphite? Graphite, if put in an inert environment, meaning let's say nitrogen or helium, you can heat those puppy up. How hot? We are looking at like almost 3000 degrees Celsius. How would you heat it up? You can have electrical resistance or basically photon-based system, radiation-based heating. You can heat it up. So what after that? Once you reach that radiative heating level, that is more than enough to do any industrial process. So even as low as like 2500 degrees Celsius, more than good enough to do anything. More than good enough. Like only few ceramic processing requires a bit higher than that, but almost nothing. Like majority of your nation can be taken care of that. So you take electricity, surplus electricity, surplus as in like the time you do not want it, you just dump it into thermal energy. Thermal energy storage buffers it out and gives you a very concentrated 24/7 stable stream. So now you have the luxury of like, oh, wind is very high in the evening, no problem, the energy storage will store it. Solar is very high in the daytime, no problems, energy storage will store it. We need 24/7, no problem. We're gonna leach energy from the thermal block. So this is a cheap solution because there is no conversion. Electricity to heat, done. 24/7. So there are some options, and again, this is just one toolkit, but it does go to very highest temperature I have seen. So there are a lot of effort being put into high temperature thermal energy storage for this reason. If we can truly solve this part, like how can we have melting metals and all that part with this, because again, radiative heating does allow you to have the highest temperature possible. We can do things. And again, this also fundamentally removes the energy storage part. Graphite block is not that expensive. And again, it does not degrade or anything, as long as you do not break the seal. If you break the seal, it will catch on fire. So as in like, it has to be in an inert environment. So processing can be, basically the impact can be reduced. Like, and again, there are some places like especially that cement kiln where you have a giant fire flame inside it that heats up the whole thing. It's difficult. Again, conduction, convection, radiation, all these three things, matching it with electricity is not as easy as you might think. So it's difficult, but it can be done. There are good attempts being made. My personal favorite is this one, but it can be done. And do not just expect, oh, why don't they electrify it? It's just like, yeah, it's going to cost 5 times more, then nobody's going to do it. It has to be cheaper, which again, for low temperature system, heat pumps are proving that. And again, once this sort of technology becomes mature, there is a good chance this will also start to, being replace fuel-fired, fossil fuel-fired heating sources. Again, temperature is there. So processing can also be done. Now we come to the most expensive aspect, wisdom. Because here's the rich nations right now have the luxury of doing remote mining, meaning Americans do not know what is the penalty of all the Tesla they are buying, because again that's being bared by some other country. And again, all the neodymium that you're consuming, this is the Chinese river in Zhangda. This the whole river became basically poison, acid rain, and not acid rain, so acid mine drainage, because they were doing a lot of mining. And this is another aspect of it. Like many times people forget, like uranium and all the nuclear fuels do not just fall from sky. They also have this, and they have extra mining side effect, which includes radioactive acid mine drainage. So it's one of those things. There is a lot of penalty of clothing industry, especially with the clothing industry that keeps changing this much. Why the heck Americans and Europeans are not aware of it? It's happening in Bangladesh. It's not happening to them. So rich nations, if they start to do local mining and local industries, it will force them to basically improve the cleaning and green technology. Can we do it? Like, for example, I'll give you a simple example. India has a giant clothing industry. Again, we also had the same issue. It's like, hey, if we have that much water dyeing industry, it's going to be expensive, because again, water cleaning is expensive. So other companies came up. Like one of company that I have covered was Indra Waters. It was using electrolysis to filter the water, not splitting the, basically different kind of system. And the benefit was they're taking the water and they're like, hey, you are paying us, right? The expense is going up, but we can recycle the water. Meaning the fresh water that you are buying, we can filter out majority of it, almost all of it, because again, thankfully, industrial processing generally only gives you one contamination. So if you know how to tailor filtration for that contamination, you can remove almost all of it and get almost all of the water, because it's not like a sewage plant where you have everything mixed. So they did that, and they're like, hey, we get less water bill. It does increase the electrical bill, because again, water is more high priority, so to say. Less water and no pollution going into rivers. So that's how you do it. That's a long-term solution. Many times people are like, oh, why don't India just export all our dirty industry? Yeah, doing that gives two penalties. First, you are not actually learning, and again, you are dependent on second countries to actually keep doing it. For example, let's say China goes through a change, radical change, and they realize, hey, we cannot keep pissing on our only water sources that we have, and they're just like, yeah, we cannot just be the dumping ground for the world just so CCP officials can have luxurious life, and everybody else is like, why there is mercury in my food? So bad things can happen. And in those sort of scenario, if they cut off, the world gets like, what the hell? So it's far more logical. Again, lithium mining done in remote location, you're not going to give a damn about how the heck you're going to filter the acid mine energy or how to avoid it in the first place. There are technology, but nobody does it because it has to be done in first world country. So rich nations can do that. And again, even from India's point of view, it's far more logical to do, because again, it creates jobs, new technology, new opportunity, really good long-term circular economy, and again, reduction of environmental degradation. I can get behind that. It is a hard problem to solve. Let that be very clear. While I can easily tell you that, oh, we have this 3000 degrees Celsius thermal block, how the heck are you going to convert the heat from that point to where you need to? It's surprisingly difficult. So it's a hard problem to solve. We have tools, we are working on it, but it's a hard problem to solve, no matter how you slice it, so to say. So stay calm. Do not be like, oh, by 2040, we're going to do this. Like, bro, if we start, then we maybe 2100. So it's going to take time. Fundamentally, it's the more deep dive you do into it, the more complex it gets. So how do we emphasize that? How do we turbocharge that? First core factor that I keep repeating, cheap and abundant power. Without it, it's not going to work. Every design, every methodology I have seen about all of these things, they assume you have cheap and abundant power, and ideally non-polluting one. So what does that mean? That means solar. Thankfully, India is going YOLO on solar. Wind. Unfortunately, India is not going YOLO on wind. Thankfully, Europe is, so at least technology is being developed. Someday we will wake up and we'll do that. We have so much sea, but at least that. And then pumped hydro, again, long-term large energy storage. In terms of basically how the heck you're going to have grid inertia, we already built so many coal power plants. We're just going to convert to E2S power solutions, basically same graphite blocks. And again, that does not require that high temperatures, like because steam, if you want high temperature, high quality steam for running a power plant, you only need 1600 degrees Celsius. Graphite blocks is like, bruh, that's like bruh temperature. And I'm like 1600 flame temperature. The water temperature barely goes to 600. So that's not difficult. And again, that will give you inertia, that will make sure that all the assets that we have built is still in use. We have the inertia, we have the assets, and again, it also has energy storage, but over short duration. Like, do expect it for like daytime peak energy absorption and evening time tapering off. pumped hydro is like overnight. So you have solar, wind, pumped hydro, E2S kind of thermal energy storage. Biogas, again, India does have a giant population. Everybody does that. And again, it's a carbon cycle neutral kind of scenario. So we have to take care of it, because if we do not, it goes into the atmosphere and it makes carbon dioxide look like a beach place. It's far more destructive. So we have to convert methane into basically less harmful CO2. So might as well use it as energy. So biogas, and how the heck you transmit so much energy? HVDC, India is going yellow on it. China is going yellow on it. China is bit ahead in terms of wind. So they are bit ahead. No nukes. No nuclear energy. I have no idea how the heck humanity keeps forgetting. Nuclear is not cheap. Take any country, check any power plant, it's never ever cheap. The basically megawatt hour that it sells is always expensive. All the benefits of that, it's 24/7. It's not that much, especially when you have the technology to solve it. And solar will keep getting cheaper. Wind will keep getting cheaper. Nuclear will keep getting more expensive. Why? Because they requires a lot of people, lot of training, lot of nuclear safety, which again, every incident, the price goes up. So, the 3 Mile Island safety cost was like X. Chernobyl goes boom, 5X. Fukushima goes boom, 10X. So price keeps going up. And every incident, and before every incident, nothing will happen. After every, oh, that could also happen. Okay, now we have to turbocharge this. So trust me, you want cheap and abundant. And not to mention the carbon footprint of nuclear power plant. It's huge. So ideally, solar, wind, pumped hydro, thermal energy storage in terms of coal power plant conversion, biogas, high voltage DC, no nucleus, and we will be good. We'll be good. That will solve the cheap and abundant. Once you have that, only then you can expect the mining industry to adopt it. Mining will not switch to electricity if electricity is so expensive. So fundamentally, it has to be cheaper than diesel. And again, all other processes, it has to be cheap and it has to be abundant. Like, here's the deal. India has spent a lot of money developing a technology. Again, we should develop it because it's a very good boom technology. And we do want aircraft carrier. We do want nuclear submarines. Those things do require technology. Awesome. Why those things? They do not require ROI, return on investment. While power plant, they do require ROI. Yeah, that part is the difficult part. And do not even Google how long overdue that project is and how much over budget it is. That's why I keep saying you cannot use nuclear for cheap power. On paper, it works. On paper, it's every time it works. It's just that we have been trying this from 1970s and we learned it the hard way. It's like people keep forgetting. That's why I say it. The most expensive part is the wisdom. We have to be very thorough about it. So this was my presentation on how do we move towards cleaning the quote-unquote mining industry. Hopefully you have liked it, learned from it. In that case, please click the like button, to show me that you liked it, learn from it. In that case, please click the like button. If you did not like it, did not learn from it, or did not enjoy it, press dislike button, press it twice to show me extra disappointment. Leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.